A circus performer intends to walk up a taut cable to a platform at the top of a pole. The cable is attached to the ground x plus 7 meters from the base of the pole, and the pole itself has a height of x meters. We want to note that these three links form a right triangle. How high above the ground is the platform? So I went ahead and I drew a picture of the situation that's going on in here. Here's the circus performer walking up a taut cable. Let's go ahead and label this with our links that we're given. Cables attached to the ground, x plus 7 meters away from the pole, so we have an x plus 7 down there. The cable has a length of x plus 8 meters, so that has a length of x plus 8. And then the pole itself has a height of x meters, so that's x. All right, so this performer's walking up to the top. Right triangle. Let's go ahead and try and write down an equation that uses some of the information that we've been given. We don't have a lot of information, right? Basically, the only thing that we have are some relationships between these leg lengths. I know that this one's length x, this says add 7 to that, this is add 8 to that, and then I know that they form this right triangle. We know something about leg lengths and hypotenuse length and right triangles, right? Pythagoras, way back when, told us that if we have a right triangle with some lengths AB, hypotenuse C, that c squared equals a squared plus b squared. Well, let's go ahead and use that. Here's some lengths of a right triangle. Let's use Pythagoras. X plus 8 is our hypotenuse. So I know that that squared is equal to leg length squared, x squared, plus other leg length squared, x plus 7 squared. Here's an equation. There's a variable in it. I can try and solve that variable for that variable. So let's do that. In order to solve, I'd like to probably first multiply these things out. Okay, so let's do that. X plus 8 quantity squared. We know that. That's x squared plus 2 times 8, 16 times x, plus 8 squared, 64, equals x squared is x squared. X plus 7 quantity squared, that's x squared plus 2 times 7 times x plus 7 squared, 49. So here's an equation where I just have each nice terms, none of these extra squared bits. To solve most equations, in particular equations where x occurs more than once, what I'd like to do is factor this, and I'd like to have it in factored form equals 0. So let's get all of this stuff over to the other side, okay? And then I'll have it equal to 0. So let's subtract x squared from both sides. If I subtract x squared from the left, that can go away. If I subtract x squared from the left, that'll go away. If I subtract x squared from the left, 16x will go away. If I subtract 16x from the right, I get to subtract 16x from the right. If I subtract 64 from the left, subtract 64 from the right, let's see what we got left. We got 0 left over here on the left. On the right, we have an x squared left over. We have 14x minus 16x, that's a negative 2x. We have 49 minus 64, that's a negative 15. So here's a quadratic. Leading order coefficient is 1. I can try and factor this just by looking at factors of negative 15, finding 2 that sum up to negative 2. Well, 1 and 15 are factors of 15, 3 and 5 are factors of 15. If I use 1 and 15, I'm not going to sum up to negative 2. But if I use 3 and 5 and make the 5 negative, those will sum up to negative 2. So we can write down our factoring. 5 and 3 are the ones that we said worked. If we used 5 negative and 3 positive, x squared, negative 5x plus 3x is negative 2x. Negative 5 times positive 3 is negative 15. So we have two solutions. From this part, x minus 5, when's that 0? Well, that's 0 when x equals 5. From this part, x plus 3, when's that 0? That's 0 when x is equal to minus 3. Here's two solutions. But we're dealing with some lengths here. We can't use a length of negative 3 meters. So our only solution has got to be x equals 5 meters.